Hey everyone, welcome back. This is lesson 4-6, row operations and augmented matrices. I also might call this math puzzles, so if you enjoy math puzzles, this might be the lesson for you. Today's objective, you're going to be able to use elementary row operations to solve systems of equations. Today's vocabulary is augmented matrix, row operation, row reduction, and reduced row echelon form. In previous lessons, you saw how Cramer's rule and inverses can be used to solve systems of equations. Solving large systems requires a different method using an augmented matrix. An augmented matrix consists of the coefficients and the constant terms of a system of linear equations. So for example, we have two equations, a system of equations, 7x plus 3y equals 4 and 2x plus 3y equals 10. We can rewrite as a matrix 7, 3, and our constant 4, and 2, -3, and our constant 10. And notice that a vertical line separates the coefficients from the constants. So these are the coefficients, they're the numbers in front of our variables, and our constant 4 and 10, they go on this right side of our dotted line. Here's an example. The question says to write the augmented matrix for the system of equations. So the very first thing we want to do is write the equation in the ax plus by equals c form. And as you can see from this problem, we already are x, y, and c, and the x, y, and c being our constant. All right, so here we've rewritten it or written it to make sure it's in the correct form. And next thing we want to do is write the augmented matrix with the coefficients and the constants. So it's not too difficult. We have 6, -5, 2, and 11. 6, -5, 2, and 11. These are our coefficients separated by a dotted vertical line, and then our constants, 14 and 57. 14 and 57. All right, here's another example. It says write the augmented matrix. This time we have 3 equations in our system, but that's nothing to be scared of. Notice that they don't all have the x, y, and the z. So what we're going to do is just fill in with zeros if we don't have a particular letter. So let's take a look at it. First of all, we want to make sure that it's in x, y, z format. So ax plus by plus cz equals d. All right, so in order to do that, we're just going to rewrite it a little bit. You should be able to do that by now. Notice the first one, x plus 2y, but I have no z's here. So when I rewrite my equation, I go ahead and write in x plus 2y plus 0z equals 12. Here I have x, y, and z, which is 2x plus 1y plus 1z equals 14. And again, I'm missing the letter x here, so I'm just going to put in a 0x plus y plus 3z equals 16. All right, step 2 is just to go ahead and write the augmented matrix with the coefficients and the constants. Okay, so let's take a look at that. Our coefficients here, 1, 2, 0. So we just fill them in, 1, 2, 0. 2, this is understood 1, 1, 2, 1, 1. 0, 1, 3, 0, 1, 3. That's our coefficient matrix. Now we're going to separate it with a vertical slashed line, dashed line. And now on this side, we're going to put our constants, 12, 14, 16. And you can see over here, 12, 14, 16. That's where we got it. So that's all you have to do when it asks to write an augmented matrix. Go ahead and try this one on your own. Turn the video off and give it a try. All right, this is a pretty simple problem. The very first thing we want to do is make sure that it's written in the ax plus by equals c format, and we are not quite there. Notice if I subtract y, or if I add negative x to either side, notice that I get 0, because when we add, we get 0 here. All right, so here we have negative x minus y equals 0, and negative x minus y equals -2. So to write the matrix, the augmented matrix, we're going to first put in the coefficients and then the constants. So our coefficients are -1, negative 1, and then negative 1 on the bottom, and our constants are going to be 0 and negative 2. Okay, try one more on your own. Turn the video off and see if you can get this one correct. All right, so the first thing we need to do is rewrite each equation in the ax plus by plus cz equals d format. And so just make sure you did that. Here they are. Negative 5x minus 4y. And notice I put in a plus 0z. There was no z in here, so I just put a filler. 0 times z is 0, so it's just a filler space to keep it in. Everything needs to have something in its place. So x plus 0y, again, plus z equals 3, and 0x plus 4y plus 3z equals 10. So I hope you got all of your x, y's, and z's. And notice you have to keep it in the x, y, z order. All right, so once I've gotten it written out, my equation is written in the correct format, I can just write my augmented matrix. So half of it's going to have our coefficient, and the other half will have the constants, our coefficients, negative 5, negative 4, and 0. Negative 5, negative 4, 0. 1, 0, 1, 1, 0, 1, 0, 4, 3, 0, 4, 3. And our constants, 12, 3, and 10. 12, 3, and 10. So I just want to make sure you see where all of those are coming from. You can use the augmented matrix of a system to solve the system. First, you will do a row operation to change the form of the matrix. These row operations create a matrix equivalent to the original matrix. So the new matrix represents a system equivalent to the original system. So basically, we're just going to be changing. For each matrix, the following row operations produce a matrix of an equivalent system. So here's some things that you can do with each of your matrix. The first thing you can do is you can switch any two rows, because really all this tells you is that 1x plus 2y is equal to 3, or 4x plus 5y is equal to 6. And we can just switch these to say 4x plus 5y equals 6, and 1x plus 2y equals 3. So it doesn't matter which order those are in. Another thing that you could do to a matrix is you could multiply a whole row by a non-zero constant. So what that means is I could take, say, row 1 here, actually, yes, and I could multiply it all by 2. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and I haven't changed my equation. My matrix is still the same. It just looks different. All right. Another thing we could do is replace a row with a sum or difference of that row and another row. So this one's a little bit trickier, but if you just look and see, you can see. So we can take 1 plus 4 and make it a new, so I could keep this first row, 1, 2, 3. And for my second row, what I could do is I could say 1 plus 4 and have 5 here. 2 plus 5, this would be a 7. And 3 plus 6, so we could have a 9 down here at the end. So what this could potentially look like, this new row, matrix, sorry, could look like 1, 2, put this 3. And then in the second part of our matrix, I would have 5, 7, and 9. All right. So all of these we're going to be working with. Basically what we're going to be doing is doing some elimination type problems. And so these are some of the things that you can do to solve for your x and y. All right, row reduction is the process of performing elementary row operations like what we just looked at on an augmented matrix to solve a system. The goal is to get the coefficients to reduce to the identity matrix on the left side. So here's what a reduced row echelon form looks like. All right, so it's going to be the identity matrix, which is a matrix with the diagonals with 1 and zeros everywhere else. Over here is our constant. So what this says, and this is what you can see why this is helpful, this says 1x plus 0y equals 5. So we can see that x is going to equal 5. And here this says 0x plus 1y equals 2. So y equals 2. So we always want our matrix. This is going to be our goal. We always want to have our matrix in the reduced row echelon form. That means it's going to be the identity matrix, and the constant. All right, and so we're going to do some samples, and it's going to look kind of crazy at first, but once we get going, I think you'll figure it out. All right, we're going to do an example, and the first ones are going to seem kind of confusing to you at first probably, but then as you get going, I think you'll figure it out. All right, so the first thing we want to do, the problem says to write the augmented matrix and solve. So our augmented matrix is going to be our coefficient matrix, which is going to be 2, 1, 3, -2. All right, and I got those numbers from right here. All right, and then I'm going to use a dashed vertical line, and that is equal to 11 and 6. So here is my augmented matrix. All right, now before I can solve, I need to remember what is my goal in solving. So my goal is to get a matrix that has a 1, 0, 0, 1, and then our constants over here. And I don't know what my constants are going to be yet, because what this is actually saying is 1x plus 0y. 0y is going to equal something, and 0x plus 1y is going to equal something. So in the end, I'm going to have 1x equals something and 1y equals something. So that's our goal. So the first thing I want you to do in order to reach our goal is we're going to try and get this position to turn to 0. So we're going to take our matrix here that we have, our augmented matrix, and I'm going to look at this, and just like we looked when we did elimination, we looked over here at the 2 and the 3. Since I want you to get rid of this position right here, I need to think of a number that I could add these two together where they would get rid of, where they would eliminate this 3, and it would end up being 0. All right, so I look at this and I think 6, okay? I think if I have a positive 6 and a negative 6 and add those together, then I'm going to get 0. So I'm going to multiply my top row. I can do this. I can multiply my top row, let's say by 3, and my bottom row, I'm going to multiply it by a -2. So 3 times 2 is 6, so I'm going to make a new matrix right over here. 6. 3 times 1 is 3, and then I have my dashed line here, and 3 times 11 is 33. All right, now I'm going to also multiply the bottom row. -2 times 3 is -6. -2 times -2 is a +4. And -2 times 6 is 12 negative. All right, so haven't really changed my equation, haven't really changed anything, just put it in a different form. Now I'm going to keep my top row the way it is. So I'm going to say 6, 3, 33. And I'm going to add these two together and put them in my second row. So 6 plus -6 is 0. 3 plus 4 is 7. And 33 plus a -12 is 21. All right, so here's what my new matrix looks like. All right, now I've got my 0 exactly where I wanted it to be. I have a 0 here. Now I want to try and solve for another 0, because remember, this is my goal right here. All right, so I've got 1 0 where it needs to be. Now I need my other corner to get its 0. So I'm going to look at that. I want this 3 to turn to a 0. All right, well, just like before when we were thinking about elimination, how could I get this to turn to 0? Well, if this is a 21 and this is a negative 21, or the other way around, then I could add my 2 rows together and it would end up eliminating that 3 and it would become a 0. So I could multiply the top by, let's say, 7, and I could multiply the bottom by 3. So let's do that, each of my rows. So 7 times 6 is 42. 7 times 3 is 21. And 7 times 33 is, I'm going to do it real quick, 7 times 33, 231. 231. Okay, put my rest of my matrix there. 3 times 0 is 0. 3 times 7 is 21. And 3 times 21 is 63. Okay, so I want to subtract this. So I'm actually going to change this to make this a negative. 3 times 0 is 0. Negative 3 times 7 is negative 21. And negative 3 times 21 is negative 63. Okay, so this time I want a 0 here. So I'm going to keep my bottom row the same. All right, 0, negative 21, and negative 63. I'm going to keep that the same. And I'm going to add the 2 together and put the answer in the top row. So 0 plus 42 is 42. All right, negative 21 plus a positive 21 is 0. And 231 minus 63, or plus a negative 63, is 231. 63 is 168. 168. Okay, so now notice I have my zeros exactly where I want them to be. All right, so now what I need to do is I want this number, this 42, to be a 1. So what could I do to this row to get that 42 to be a 1? Well, I could divide, or I could multiply by the inverse, 1 over 42. Just divide everything by 42, and let's see what happens. So 42 divided by 42 is 1. I'm going to put it back over here again. 1. 1 over 42 times 0 is 0. And 168 divided by 42 is 4. So I'm going to just put the 4 in here. All right. So now I'm looking pretty good. I've got my 1 and 0. And now let's look at this row again. I still have a negative 21 here, and I want that to be a 1. So how about if I divide everything by, or multiply everything by 1 over negative 21? Okay, so 0 times 1 over negative 21 is 0. So I'm going to put that in this spot here. Negative 21 divided by, or multiplied by 1 over, is positive 1. And then negative 63 divided by negative 21 is positive 3. All right. So now we have reached our goal. We have the identity matrix and zeros everywhere else. So now we can rewrite this to say 1x plus 0y equals 4. And 0x plus 1y equals 3. All right, so 1x plus 0y is the same as x equals 4. 0x plus 1y is the same as y equals 3. Now, we always have to go back and check to make sure that our solution for 3 is correct. So let's go ahead and fill it in. 2 times 4 plus 3, that's 8 plus 3 is equal to 11. So that's a check. All right, and then 3 times 4 plus a negative 2 times 3. 3 times 4 is 12 plus a negative 8. Does not equal, oh, oops, negative 8. That's not negative 8, that's negative 6. Okay, so 2 times 3 is negative 6. So 12 plus a negative 6 is indeed 6, and it works out, and so that's a check. So in the end, your solution set is 4, 3. Now I know that was kind of confusing, so we're going to do another one and give it another try. All right, let's try a different example. Again, it says to write the augmented matrix and solve. So our augmented matrix is going to be 8, negative 5, 5, 8, and our constants are 18 and negative 11. So here's my augmented matrix. Now, remember what our goal is. Our final goal is to get a matrix, which is the identity matrix. And then on the other side, we want to have our constants. All right, so here's our identity matrix because we have 1s in the main diagonal and 0s in the other place. So the first thing we want to do is get a 0 in our bottom row. So I'm going to go ahead and leave my top row the way it is, 8, negative 5, and 18. And I want to change something so I can get my bottom row to have a 0 here. Well, one of the things I can do is I can add the two rows together, and whatever I get I can put into my second row down here. So it's not very helpful for me to just add straight right now, but if I change each of these, if I multiply this by a positive 5, let's say, and this by a negative 8, that's going to give me a new matrix of 40 plus negative 25, and 5 times 18 is 90, and then negative 8 times 5 is a negative 40, negative 64, and a positive 88. So if I take these two that I've changed up and add them together, 40 plus a negative 40 is 0. I'm going to put that in the new place. Negative 25 and negative 64 is a negative 89. And 90 plus 88 is 178. All right, so here I have my new matrix, and I have a 0 right where I want it to be. Now I want this negative 5 to become a 0 also. So again, I'm going to keep, this time I'm going to keep my bottom row. I'm going to keep it 0, negative 89, and 178. And I'm going to change up my top row. So now I can look at, I have a 5 and an 89, and I want to get those to multiply together. So let's see what happens when I add them together and get 0, so I can get rid of this 5 up here. So I'm going to multiply the whole matrix on the top by 89 and the whole matrix on the bottom by a negative 5. So let's see what happens. So 8 times 89 is 712. Negative 5 times 89 is a negative 445. And 89 times 18 is 1,602. All right, so here's part of my new stuff. And if I multiply 5 by everything, negative 5 times 0 is 0. Negative 5 times negative 89 is a positive 445. And negative 5 times 178 is a negative 890. All right, so I already have my bottom row. I want to just add these two together and make them into my top row. All right, so 712 plus 0 is 712. Negative 445 plus a positive 445 is 0. And 1,602 minus 890 is 712. 712. So now I have my new matrix, and I've got my zeros in the exact spot that I want them to be. Now all I need to do is get these two numbers, 719 and negative 89. I want those to turn into ones. So I can look at that. If I divide everything on the top by 712, 712, 712, 712, I end up getting 1, 0, 1. And if I divide everything on the bottom by negative 89, let's see, if I divide everything by negative 89, I end up getting 0, 1, and 178 divided by, actually, let's see here, 178 divided by 89 is going to be 2, and I think that's going to be a negative 2, so let's just check. I think I lost a negative somewhere in there, or I think I added a negative somewhere in there. So now I can see that 1x plus 0y equals 1, and 0x plus 1y equals 2. And it may be a negative 2, but I'll check that in just a minute because this number was negative on ours. Not sure where I made my mistake, but it's pretty close. So we should say x equals 1 and y equals 2. So let's go ahead and fill it back in, check our answers here. So we have 8 times 1 plus negative 5 times 2. All right, and that really should be a negative 2, like it said it should be. So that's 8 plus 10 equals 18, and that is correct. And then our other one says 5x, and x is 1, plus 8 times negative 2. 5 times 1 is 5, plus negative 16 equals negative 11, and that is correct also. Here's another one. I'd like you to give this one a try on your own and see if you can figure this one out on your own. So put the video on pause, give it a try, and then come back. Okay, so the first thing we have to do is write the augmented matrix, and remember that's going to be our 4, 4, 1, 3. So we're going to put that in here, 4, 4, 1, 3, and then this dashed line, and then a 32 and a 16. All right, and that tells us what our constants are. All right, so there's our augmented matrix. The next thing we need to do is remember what our goal is. Our goal is 1, 0, 0, 1, and then our constants on the other side. All right, so the first thing we want to do is solve for this 0. So I'm going to go ahead and leave my first matrix my first row as it is, 4, 4, 32. All right, now I want to figure out what can I multiply the two by, add them together, and end up getting 0 here. Well, I can see if I multiply everything on the bottom by 4, negative 4 actually. If I multiply that by negative 4, we will have on the top row 4, 4, 32, and on the bottom row would be negative 4, negative 12, and negative 64. When I add those two together, 4 plus 4, negative 4 is 0. 4 plus a negative 12 is negative 8. And 32 plus a negative 64 is a negative 32. All right, so now I want to keep my bottom row as it is. So I'm going to go ahead and rewrite that again to keep it as it is. negative 8, and a negative 32. And I want to change this 4. So what can I multiply both of the equations by to get a negative 8? Well, I can multiply them both by 2, or the top one by 2. So I'm going to say 2 times 4 is 8. 2 times 4 is 8, and 2 times 32 is 64. And I can go ahead and keep the bottom as it is, negative 32. So now I'm going to add those together and put them in the top spot here. All right, so 8 plus 0 is 8. 8 plus a negative 8 is 0. And 64 plus a negative 32 is a positive 32. Well, I'm almost there now. I've got zeros where they belong. I just need to get rid of my 8s. So I can divide everything on the top by 8. And that's going to leave me with 1. I'm going to put it over here. 1, 0, 4. And if I multiply everything on the bottom by negative 8, that leaves me with 0, 1, 4. So I can see that 1x plus 0y equals 4, and 0x plus 1y also equals 4. So my solution set is going to be 4, 4. Now we always need to go back and check our work to make sure that we did it right. So let's use our first equation. 4 times 4 plus 4 times 4 equals, that's 16 plus 16 equals 32. So that one is correct. So next we have 4 plus 3 times 4, and 4 plus 12 equals 16, and that is correct also. So our solution set is 4, 4. I hope you were able to figure that one out after a few minutes. I know it's kind of complicated, but I think you can do it. All right, here's one more I want you to try on your own. Turn the video off for just a minute and give it a try and see how you do. All right, the first thing it says is to write the augmented matrix. So before we can write the augmented matrix, though, let's take a look at this. It's not in the x plus y format. So let's add 9 to both sides, plus 9x. And so we have 9x plus 3y equals 15. And over here, let's go ahead, and I like to keep my x's and y's as positive as possible. So I'm going to add a 6x to both sides, and I'm going to subtract 10 from both sides. So I end up with 6x plus 2y equals negative 10. Now you may not have come up with that number, and that's okay, because in the end we all get the same answer anyway. So to get our augmented matrix, then we're going to have 9, 3, 15, and 6, 2, negative 10. All right, so here's our augmented matrix, and let's remember what our goal is. Our goal is to have 1, 0, 0, 1 with our constants at the end. All right, so the first thing I want to do is try and get this 0. So I want this to become a 6. So I'm going to go ahead and keep my top row the same for the first time. I'm going to keep it 9, 3, 15. All right, so what can I do to get rid of my 6? Well, I know that 9 and 6 are both factors of 18. So if I multiply the top by 2 and the bottom by a negative 3, let's see what happens. 2 times 9 is 18, 2 times 3 is 6, and 2 times 15 is 30. Negative 3 times 6 is negative 18, negative 3 times 2 is negative 6, and negative 3 times negative 10 is a positive 30. And I look at this, and when I add these two together, I end up with 0, 0, 60. All right, which would come over here, 0, 0, 60. But let's look at this for just a minute before we go any further. So I see that this is going to be 0x plus 0y equals 60. So that means 0 equals 60, and that is not ever true. So our system is going to be called inconsistent. All right, there you go. So our system is inconsistent if we end up with zeros like that. All right, so that's the end of our lesson for today. I know that's very long and complicated and can be confusing. So tomorrow in class, I'm going to show you how to do all of this on the calculator. So it'll make your life much easier. Hope you have a great day, and I'll talk to you soon.